Mm. All right. And here we go. Streaming again. All right, guys. How's it going? Yeah, it's Tuesday. It's 8 o'clock. So let's try some code. Yeah, so today I'm going to keep working on the file system library in Swift. And yeah, I've got some work I did offline. Maybe we can start there, talk about what happened since the last time this was shown on stream. You can follow this project on GitHub if you want. Let me just close this very distracting thing here. Okay. So if you go to D1, Pathos, you get this project. The branch I'm working on is called Next. So all the progress is happening here. I've been making little changes here and there every day, just whenever I can sneak in some time. So hopefully this stream we can get some more stuff done. Let me just do this real quick as well. Okay. Yeah. So what happened since the last time? I don't know how long ago was the last time, but let's say it's a week ago. Oh yeah, I'm pretty sure I remember this. So we added, let's just go over the code. So here is the source directory. Yeah. So I think on stream I added like the plus operator for joining paths together. Off stream I realized the stuff I added on stream is not adequate at all. So I added a whole bunch of stuff. So I'm thinking about making an individual video for this. But the story here is we're joining. I want to be able to join paths of different types, right? So I have this path type, which is your generic path. And then I have these pure paths that can work across platforms. So you can create a POSIX path, for example, on Windows, and it will work. So how do we join those two together? Well, on stream, we already made this protocol such that, for POSIX platform, a bunch of things can convert to it, right? So here's the definition of the protocol itself. And then here is the path itself. It literally just returns self. And then here you have string. Let's take the Swift string and make it convertible to POSIX path. And then here's a binary string, which is really a contiguous array of integers. And yeah, it can also convert to string, right? So I use this protocol on stream to write this join method, which is forwards to this one, which is really converting everything back to using the protocol and then join them together, do whatever is needed. And then off stream, I realized, right, I can't simply just implement plus in terms of join because think about this for a second. If you have a plus operator that takes a string and another string, then it's really it's ambiguous whether you're joining the string together or you're joining two paths together. And I do want to be able to say, if you have a path and a string, and string starting from the beginning, you will be able to call this operator and it'll work. So that's essentially why I needed to implement a whole set of plus operators, so that if you're adding two strings together, you add the default Swift behavior as well as the contiguous array, and then only when one of these your chain of operands is a path or a pure path, would we actually create a path as a result of the plus operator. And then within this set of problems, there's also adding a pure path and a path. So in that case, I want to have path. So that's why you have essentially you have a combinatorial problem. Well, combinatorial. It's like the first operator could be one of 4 types, and the second operator can be one of 4 types. The return type is one of 2 types. So just imagine multiplying all that possibilities together, and then you take away a few where the both operands are strings or contiguous arrays, right? So, anyways, that's a long-winded explanation for that little part that happened off stream. And then I added, I think, was this off stream? Working directory. So yeah, I started implementing platform-specific stuff. So I believe, let's say path plus, let's look in Windows is more interesting, right? So here's how you implement getting the working directory. I actually made a poll on Twitter about what's the best name for this, and working directory is what I end up with. But on Windows, you essentially call this get current directory thing, and it will work. So yeah, so implement that for POSIX and Windows, and then Windows CI. So every time these codes are wrong, now there's a Windows task, and it's actually really cool. It installs Windows on Swift on Windows. It installs a Ubuntu image on with Windows WSL, Windows something for Linux. Anyway, you install Linux on Windows, and then you install Swift PM in the Linux image, and then it's not an image, it's whatever. And then you call Swift PM within it, because Swift PM only works on Windows on Linux and Mac OS. So you call it within it, but you give it a bunch of options to say, hey, link this, link that, using the Windows installation of the Swift files. And then you build your project. So basically you cross-compile your test into a Windows executable within Windows for Linux. Windows SL, what is it called? Windows WSL. Windows system for Linux? Subsystem for Linux. Okay. Anyways, you use Windows subsystem for Linux to call Swift PM within the Ubuntu instance, and then you cross-compile all the tests into an executable for Windows, and then you go back to your host system, which is Windows, and you run that executable. So that's what this last step is about. So yeah, all it does is literally, go into the build directory, find the build, and then call it, right? And because of XCTest running in standalone mode, it's just output is almost the same as running it in Swift PM directly. Anyways, so now I have tests for Windows. And then I started working on metadata. I think this is one of the first things we're gonna work on today. Yeah, metadata is things like your modification time, creation time, file size, permissions, and etc. There's some subtleties here. We'll get into it later. And then there's revision of this path stuff. I think is what I actually showed you in the code. But as you can see, the test is also pretty extensive. I covered all the combination cases, and then I made this little property wrapper just for fun. I mean, not just for fun, but it saved a few lines of code. Here we go. Yeah. Anyways, so that's it. That's what happened off stream. Yeah. Okay. So let's as you can see, I'm at the metadata branch. So let's take a look at metadata. All right. So I have this pull request. I've implemented metadata for Darwin, meaning Mac OS, iOS, tvOS, iPadOS, which is they're all the same as far as we're concerned. Next, I'm going to implement it for platforms that use Glibc, which is Linux BSD, and then we'll move on to Windows. So I think that's the first thing we'll do today. But let's go over what happened so far. So I mentioned there are some types created for metadata. So here's the metadata type. Let's show it in code. Why not? Yeah, let's just do metadata. Okay, so metadata, as I mentioned earlier, has a file type, some permissions, size, easy to understand, and then these time attributes that has like last accessed, last modified, and the creation time. If you're familiar with this stat API on POSIX, you'll notice this 3 times is not the standard POSIX stat. So what happens is, if you just look at stat, right, you will get this data structure that has these 3 times. So there's the last access time. Okay, we have the accessed, and then you have the modification time. Okay, we have a modified, and then this last one is time of last file status change. Okay, understandable, right? But if you remember, what we have is a creation time. So what happens here is on Windows, this is slightly different. This doesn't exist, and Windows does give you, I think, roughly equivalent of these first two properties, but the third one doesn't exist. And in both, I guess, quote-unquote modern version of POSIX systems, for example, 64-bit, let's just keep reading, 64-bit Darwin, right? You have 64-bit inode enabled, then you'll get an additional definition property in the definition of stat, struct stat, which is birth time, okay? The time of file creation. So this matches the other attribute, file attribute that Windows gives you. And there's an equivalent of that on Linux as well. And that's, I think, why we need to have a separate implementation for Mac OS and Linux. And on Linux, I believe, I was looking at this earlier. It's probably somewhere in an open tab. Yeah, Linux kernel revision history. I think at some point, I think it's 4.11. Yeah, at kernel version 4.11 was when this burst time was also added to Linux. Yeah, we'll deal with that very soon. But I'm kind of curious to see what here we go. So 4.11 is from 2017. Is this old enough? Yeah, July is the next version. So I guess our library won't work, well, for this very specific thing, will not work when your OS is below this. Well, we'll see. Okay, you know what? Let's just get into it, because let's go back to the pull request. If you just look at the continuous integration, the only tests that are passing are the ones for macOS. And the tests for Linux are failing. I added all the officially supported Linux distributions. And then for Windows, obviously, it won't work because I haven't implemented them. So let's implement them, okay? So I have a file called metadata plus Darwin. This is where, things are, this file looks simple, but it actually calls into things like, this initializer or file time, right? Things like that. So let's implement this for Linux. I don't know what's the best way, though. Let's see. Can I have a DigitalOcean droplet that I can use. Do I mind showing the IP? Give me just 1 sec. Okay. All right. Here we go. So here's all I need here is to run this man page and kind of look at the stat definition. Because I know, so what I need is to run Statx. Statx is like another version of stat, extended, and then we'll get the good stuff, such as, STX B time. This is what we want. And it has this stat timestamp. What is that? Can I look at this? No. Maybe it's in the manual. Statx b timestamp. Okay, let's see what's in here. All right, we've got a second and nanoseconds. Okay. Actually, I really like this way of explaining the documentation. So let's do this. So there's the file time. Okay, so this is good. This seconds, number of seconds since right, and then let's just get rid of that. And then this is actually very interesting. Number of nanoseconds since seconds. This is a really interesting way to explain it, right? This is very clear. I feel like there's established the relationship between these two. Okay. All right. So we have TV sec and TV in sec. Very, very easy to understand. Let's do that. Update file time document docs. Okay, so this is that change is kind of irrelevant to this branch. So yeah, I'll just make a separate branch for it. Okay, let's grab the that thingy, and then what should we call this branch? Update file time docs, and then we'll just cherry pick that. Not this thing. Oh, I can't because that file doesn't exist yet. That's fine. Abort. Okay. Let's go back here. Forget about that other thing. Never mind. Oh, this is wrong branch. Metadata. Yeah, I did have a branch called Metadata. I can delete that now. Okay. All right. That's fair enough. We'll just keep it on this branch. So let's implement metadata for systems OSs with glibc. I'm just call it glibc. It's more fun to call it glib, right? Glibc. Okay, let's do it. Metadata plus glibc. All right, and we're just straight up going to if can import glibc, and if why is this not? Oh, I wasn't using that file for some reason. Okay, what is this? Okay, import glibc. Okay. The tricky part is I can't. Oh, I can run this in. Yeah. It's not tricky at all. What am I thinking? Guess we can close a few things. Let me just close this. So I can run this with test Docker. So that means I need to launch Docker daemon that I don't normally run by default because I'm not a server developer. Okay, so we can run test Docker and find out in a relatively soon manner whether we've made a mistake. And with, source-kit LSP, with Vim, we should be able to have, live editing feedback as well. So it should work out pretty well. So that's that one, this one. For some reason, it's trying to run missing argument for permission size, blah, blah, blah. What is this? Base address, POSIX helper. Okay. Value of optional type must be unwrapped. So apparently on Linux, this is not an optional. Stat doesn't take an optional. That's fine. I'm not going to even use stat on Linux. Okay, interesting. So this helper's POSIX helper doesn't really help at all. So I might as well move them to, where is stat called? It's probably here. No. It's, right, so we call it where? It's going to be path plus POSIX, right? Yeah, it's here. Okay, so this really should be path plus Darwin, really, right? Oops, what did I type? Path plus Darwin. Okay. And here we go. If can import Darwin, and if roughly this is correct. Okay. And then we go extension path. Come over here. Grab the good stuff. Yeah, so this is guaranteed to work, right? And then we can go here and say these guys are not for POSIX per se, they're just for Darwin. Right. Can make them private for now. File private. Okay. So POSIX helper now just have this mask thingy. We'll have to figure out the equivalent of this on Linux with Statx. In fact, let's do it now. So those are for the permissions, right? Oops. Hello? Okay. Mask-based indicating fields. Attributes. Oh, let's just read this a little bit. Well, let me finish rearranging this first. Feel like this can go IFMT. Let's just search for this real quick. IMFT. I don't assume this exists here. Okay. All right, so I'm just going to take this and put it here for now. Oh, not here. It's path plus Darwin. Yeah, just put everything here. Then I can delete this awkward file. Yup. Okay. I'm gonna rename this as well. What do I call this? I don't know, Docker, something like this. Okay. So we should run into some build errors, but not those ones. Those are where I was not expecting those. So this is a 525 Bionic. I shouldn't use Bionic. I should use the latest one. Oh hey, look, we built and ran and everything worked. Yeah, that's because, well, that's good. That's a good sign. Let's just commit this. Wait. Yeah, commit this. Make Linux project build on Linux. So I guess I'll push this to the pull request for now. These can all be considered part of this pull request. Okay. Okay, let's move on. I can close this now. Droplet. Okay. All right. This file doesn't exist anymore, so go away. Where were we? Metadata plus Glibc, right? Let's do this. So in Darwin, we have this initializer. We essentially need to do the same thing for POSIX. Well, no. For Glibc. Okay? But instead of converting a stat, we're converting one of these, which is Statx. So we have a Statx, and inside Statx is a bunch of stuff, and we need to figure out the stuff, right? So let's go to POSIX file type. This can be totally different. We may have to have a Darwin file type. We'll see. We'll see how much Statx is different. Let's try to see what STX mask is. Okay. STX mask, the same format as a mask argument. Wait. Mask argument is used to tell the kernel, call it in it, it's or the combination of the following. Okay, so we can get all kinds of stuff, all of the above, b time, 1 b time, all. So we really want to pass in this, right? Let me actually get the signature of this function. So when we call this function, we need a feed. This is a file feed. Okay. So we need to open the file. Okay. Wait, that doesn't make sense. Let me actually read the flag. So we give it the flag, we give the mask. Aha, okay. So this mask tells us what's in here. It's like a self-describing thingy. Invoking, okay. So to access there's some extra space here, awkward. To access a file's status, no permission are required on the file itself, but in the case of Statx with the path name, search permission is required on all the directories in path name that leads to the file makes sense. Use to identify the target file in one of the following ways. Okay. Absolute path. If it begins with slash, then it's absolute path. In this case, dir feed is ignored. Relative path. So string that begins with a character other than the slash and dir feed is at fdcw, then the path name is a relative path that is intercepted relative to the current working directory. Aha. So if it is a relative path, we want to pass this and the string. Directory relative name. The string that begins with a character other than the slash, and there is a file director. Okay, so we can do it relative to a directory, but I'm not interested in this for now because our input is a path. Path could be relative or not, right? By file descriptor, if path name is empty string, specify. Okay. So, all right. So looks like when I call this, all I need to do is passing this flag, as well as the path name, and then for the flag, yeah. Let me just write this. So we have a path plus POSIX. No, not this one. Path plus Darwin. Okay. Okay, let's do this. It's path plus Glibc. Right? Wait, why is this here? Okay. A metadata plus Glibc. Okay. Ah, I see. I was confused. So path plus this. Why does it have this? Right, I need to create a new file. I was confused. It was like, which file does it go? So path plus Glibc, which is analog to path plus Darwin. Let's import all of this. Wait, how does one handle? Well, we'll think about that relatively soon. So if can import Glibc and if, okay. And then here we can start copying this just for the signature. So we have this follow link thingy, and then depending on whether you want to follow link, we call two different things. I don't know if a Statx has a symlink version. Add symlink no follow. Passive and symbolic link, do not dereference it instead. Okay, so this is one of the flags. Flags. Okay. I guess easy enough. So let's start with the flag, right? Flag is an int. A mask. Flag and mask are different. Okay. Let's start with the flag, which I assume is an int32. Flag. And then what are the values of flags? Flags can be used to influence path name based lookup. A value flag is constructed or in together 0 or more of the following. Okay. Empty path. Okay. No mount. What sort of synchronization kernel do? Okay, so looks like the only thing I need to care about. Wait, so or means we can start with 0, right? Okay. Got it. Follow same link. If we do follow same link, I think we do 0. Otherwise, we do add symlink no follow. Add symlink no follow. Or is no follow is one word, I think. Okay. Cool. And then for mask is it's an unsigned integer, I think. Oh. Mask. We'll just do all, right? Because I want this for sure. I don't want the blocks, really. So I can try to micro optimize this a little bit. Yeah, I don't want GID UID for now. Oh wait, this guy does have this. Huh. Mode and type. Let's just do stat all for now. Or, yeah, because I want B time, right? So I do want type. I do want a mode. I don't know what nlink is. Probably not. Probably not UID, GID. I do want these times. Some of them at least. I know number I don't really need. I do need this. I don't need blocks. What is blocks? Number of blocks allocated. Okay. And then there's also device. Okay, I'll just do Statx all for now, I guess. Oops, that's not what I wanted. Okay. All right. Now we have our flag, we have our mask. So all that's left to do is calling Statx. Calling Statx. So let's call it, right? What was my conclusion? Ah, yes. This. So I want to call it with this feed. So it goes like stat x and then that. And then path name, that's the good stuff. Wait, there's something I need to do here. It's like map with unsafe string or something. This stuff with unsafe buffer pointer, yeah. And I had to false unwrap this. Okay, so let's just unwrap it early. Base. Path base address. Or that's fine. Else Okay, get that out of the way, right? So now we have our pointer, path base point, base address. And then we have our flags. And then we have our mask. And then we have the actual object that we need to return. It's a Statx. Okay. So I think I'll do var stat equals Statx. And then we give it the address. So this will return an integer. So let's look at the return value now. The returned information. This thing we will need to go through a little bit. File attributes. Compressed, immutable. Append. No dump. Encrypted. Okay. Return value. On success, 0 is returned. Otherwise, -1 is returned. Okay. So if I guess 0 is not this, I assume we use error no. Okay. Error no is set appropriately. It's good when you have something that's appropriate. Okay, so this is where we throw a system error. And we'll give it the code error no. So, okay, so next, we now have a Statx object. Right, so now we come back here, right? Given the Statx, we want to construct our little separate fields now. You know, before I go too far, let's verify basic errors. I think if I did everything correct, which is unlikely because I just literally handwritten everything without actual, feedback, things should compile. But unlikely. Aha. Complaining about binary string. That's not a good sign. It wants some parentheses here. All right. I have a feeling. Let's just do it. Get it out of the way. Yeah, that file is going to get reformatted. Okay. What is this? So something about binary string is wrong. Wait, it's complaining these symbols don't exist. That's not a good sign. Oh, because I haven't imported Glibc. Oh my god. Stop this. Stop this foolishness. Okay, why is the build context so darn big? Hold on. Let's get rid of dot build. And then what's in temp? Swift format. Oh, that's fine. Okay. I don't know. Chad, how you doing? Wait, this is taking forever. What's going on? Test Docker. Yeah, why is it not? Also, Bionic really is bothering me. What's the latest? Focal. Can we switch to focal? Latest LTL, FTL. No, that's faster than light. Long-term support. LTS. Okay, at least this is doing something. I don't know what's going on with the other one. Okay, we're building the image. All right, here we go. So we got some of these same errors. Statx is being complained about not existing. So is it because I didn't save this file? Okay, symbol not existing. Oh, it's still a problem. Uh-oh, that's not good. So it's not in Glibc. That's an interesting problem. Really? Well, let me simplify this and figure out what the other errors is about first. So it's complaining that we're using a private type in path plus joining. Ah, I think I've ran into this before. Path plus joining. Okay, so it's using binary string. Binary string is a type alias, I believe. That's this, which is POSIX string, which is public alias. So I'm not sure why is it saying it's claiming that is private, unless let's look at the definition of path. binary string. Right, even this is using binary string. Why is this not a problem? Oh, I see. No, I don't see. Let's take a look. So we have a type alias here. Oh, it does not say public though. And then there's associated type. Aha, I think it's because of this. Let's look a look at each of them. So what if I make this public? Does that change anything? But if that's public, pure POSIX, that means, wait, what? Why does this need a binary string thing at all? Okay, it's complaining about the same thing. So let's take a look at this, I guess. I mean, this protocol is just exists for debugging purposes. Let's just comment it out. Sometimes the type alias, for some reason on different platform, interact differently when you have when it's spelling with the type alias. Okay, looks like that is the culprit. I've definitely have seen that before. What if I delete this? No, not this, but binary string. What puzzles me is why does the Windows one have a type alias there? Like, is this really needed? I have a feeling it's not. Uh-oh. That's not good. Oh. Okay, what's up with this crash? Right. I don't really need inlineable there because Swift will do the right thing if I trust. Okay, so now I just don't have the FMT. Because I made it private. Right. Okay, so the type alias is not necessary, right? I deleted it, and now here we are. Everything's working. Okay. That confused me a little bit. Yeah, this build context is ridiculous. Even 90 meg is ridiculous. Okay, so we're good as long as we comment out the path representable thing. Just to make sure, I'm going to comment it back. Make everything back. and see that's the problem. Okay, so the root problem is yeah, is this this thing. So I'm gonna rename this because it's just for debugging purpose. So being slightly strange is okay. So binary string like instead of binary string. Or I can call it representable, but again, this is really just for debugging. So yeah, I really should write this on Linux, but I'm using the same PC on Windows to do the streaming. Yeah. And hopefully this is why is it stuck? I don't know. So this should fix that. Huh. There's more stuff. Right. Okay. So that's a weird, quirky little problem. The next problem is the big one, which is apparently we don't got no add symlink no follow. That's a big problem. I need that. Please. So importing Glibc is not enough. I mean, I'm not surprised. Yeah. Right. There's a syntax error there. So I guess I'll put it at the end. I really only care about the other problem though. Please let us that symbol exist. This is a warning error. Oh, but that's warning. It's all about this not being used. So we do have this symbol. Okay, that's encouraging. So I assume this is okay as well, right? Yeah, it's pretty safe to assume that exists. It's unused, but it exists. Okay, you know what? This is getting a little tiring. Let's do it this way. Yeah, I like this layout a little better. Okay. So I assume these things can work as well. I don't know why. I think I'm pretty sure. I'm really happy we're recording everything here. I want to go back and see the error where it complains that those things don't exist. Oh, this doesn't exist and this doesn't exist? Statx. That's interesting. Huh. Now what? Do I have to write my own extension? Yeah, I probably have to do that, huh? Now I'm thinking I didn't include that created file creation time in the older version of this library. I wonder if I ran into the same thing and tried to do this and it failed, and then that's the end of that. Because that sounds reasonable. Sounds like something that I would do. Okay, so how should I proceed here? This is a long shot, but probably won't work. For Linux Foundation only. Target OS Linux. Oh no, they wrote their own. There's no Glibc Statx function, must be called using syscall. Oh no. But this is actually very helpful for me, right? Because this is for Foundation, which is probably implementing the same thing I'm doing right now. Yeah, this is unfortunate. Wait, they're using a stat buffer here. What are they doing with the B time? B time. I'm not sure why they're doing it this way. I guess this way they don't have to define Statx, but I know Statx. Oh, Statx doesn't exist neither. So what are they doing with the B time? So they initialize it to 0. And then they're like, if they exist, you make a time spec, yeah. Oh, they just return it as a separate thing. Wow. So they use the stat struct. How do I feel about this? How do I feel about this? They're also using this. Right. They're using no follow, which is interesting. So I can just yoink this. Wait, what's this? Okay, that's hopefully unrelated. So they have to call stat with system call. Okay. I mean, let's just try it. Let's just try it. Okay. GitHub has started to do this annoying thing where they had this bug of extra space at the beginning. We copy code from it. Okay, so what do we not like here? If target Linux OS, where is S size T defined? So I can get rid of this. And another one of these can be deleted, right? Okay, this is matching. And if def this, okay. All right. So use syscall here. We shuffle things in and out. Then we get this stat with b time function. This is interesting information. So I need to I need the flag. So let's include that. Stat with b time. So this is what they really want to use, even though Statx is right here. That's because they cannot get a Statx struct out. So they have to use a stat struct and a additional time spec object, which is understandable. But here I'm also going to include this because sometimes I do need the follow link thingy. So flag needs to be here. And yeah, everything else is okay. Oh, I'll include it. So flags. Okay. Buffers there, and then they create a stat here. Stat with b time. Okay, good. What's this else? Oh, else is a dummy version. I don't need this, right? Yeah. Okay, so we have b time. We're shuffling the information back with the stat object. Interesting. Okay, so can I call this now? Is this how it works? You just throw in a C header and things just show up, right? So I could definitely make this, and then I can do the b time with, it sounds like a show name. Stat with b time. Mr. B time. I think you just give it the path and the flags and mask. I don't think is necessary anymore. Yeah, no mask, just the stat buffer and time spec buffer. So we need a b time spec. Okay, and then the stat buffer, the b time buffer. Right. Well, let's just compile and see what happens. What could go wrong? Right, same thing. I guess we don't need this anymore, so that's good. Stat with b time is it unused? Yeah, that's because I need a I think I need a module map for this. Right? Swift PM module map. Or do I? Wait. Sources, pathos, right? Include stat Wait, where's my header file? Oh, it's in POSIX. What if I move it into include? Does that change anything? I just need the documentation. I just like picking from random. It's not very interesting. 3 points. Yeah, this one looks more interesting. No, that's the same one. Okay. Write a module map. Where is that? I mean, I've done this before. I just need to do it. Right. Also, we can look at things like, yeah, we can look at, for example, yams, right? There's a module mapping here. Yeah. Yeah. I have no idea. I feel like this is wrong, but it's funny because like this is literally things I've done in the past multiple times. It's just I don't remember. Okay, let's try this. Okay, so this project has a C thingy. Put your C code inside the project. Configure. Okay. Do I really need to? I guess let's try it anyways. C, add a node. C, pathos. I don't know. Maybe underscore this if I can. Okay, and then I guess I'll just move this whole thing to underscore C pathos. And everything is here now. C pathos. Statx can still be here. And then we can do that umbrella header thingy, right? Wait, that's it. It doesn't. They don't even make an umbrella header or module map. That makes sense because we're not linking into a statically linking to a binary, so this is not necessary. Okay. Should I just also make a dummy file? Okay. And then let's update the package manifest, I guess. Yeah. So packages, target, C. Well, let's build it on Mac as well. Okay, looks like it's happy. So this is not a good sign because I assume the header being in either module doesn't make a difference here. But let's make this target a dependency for this target. Okay, all good. This is stalling. I don't know why. Yeah, I don't know. Wait. Path plus glibc. Import C pathos. All good here. What is in here? Retrieving definition. I am assuming it's not going to find anything. Glibc. Wait, not this one. This one. Jump. Nothing. I built it. Nothing. I just want to see what the generated header would be. Let's do some drastic stuff here. Build succeed, please. Oh. Okay, show me. Nothing. That's interesting, right? Does this guy has a sample source cccc container cccc? Okay, Swift PM. Interesting. This is a C library. Oh no, this is some random library that. Okay. I see. They're creating a wrapper for it. Also, never call your library Swift wrapper. Oh my. Don't do that, please. For a tutorial, it's fine. Right. I think there's no symbol because we're not on Linux, which is understandable. Stat with B time. Did I spell it wrong by any chance? Stat with B time. Flags. Oh, flags. Okay. I'm starting to think. Mask. Statx. Oh wait, did I think I uncommented too much stuff. I'm starting to think this is not good streaming content. Me doing research. So maybe if I can make this work, I'll just turn off stream and come back later and update you guys. Because it's a silly problem. Like I think it's doable totally. I need to figure out how to hold Swift PM correctly. Right, so it just comes down to stat with B time not existing. What if I make the compile condition a little lighter? Maybe that flag doesn't exist, right? Which totally makes sense. I mean, which could make sense. I mean, Oh. Okay, so it's the compilation flag in the header file that I stole. That's the problem. Okay, so we need to include this, no problem. Let's keep going. Oh, make dev. Oh, that's one of those other function that I didn't include when I stole this. Where was it? Did I close it? I have a feeling that's the real problem. The fact that I don't really need a separate module for this. No, it's not this. Where is it? This. Make dev. I see. But I don't really need the dev, so maybe I can just do 0 here. Actually, just ignore this. I think it's fine too, right? At fdcwd doesn't exist. That's interesting because clearly it should, right? Where is it defined? It's gonna be one of these. Sysstat probably. Yeah, probably missing some headers. Sysstat, it's, let's see, types is included, stat is included, standard. Okay, this one it was not included. Linux stat, what is that? Not sure, but we made some changes. Time to find out what that does. Oh, I think we've compiled the header correctly. Oh, that's slightly surprising. Okay, Now what? Let's resume the error handling here. If this isn't 0, we throw the error number out. Otherwise, we can return our metadata. We can construct metadata later. Okay, nice. Now the real question, do I really need this module? Also, what is the right flag? Let's see, syntax, wait, Swift PM fucking syntax.com. I don't know. Linux. OS. Supported platforms. Nope. Swift PMC compile flag. I think it's compiler flags. No, this is just discussing some future features. Swift PM C if Linux. Yeah, basically I do want this flag, right? Because obviously these things won't work outside of Linux. So this is the old proposal that adds the C language target support. I don't know. Clan OS compiler flag C. Clan if Linux. No, I don't want to learn about triples. I just want to learn the syntax. Is it this? Wait, there's a final thing. which is this guy's unsigned integer. So now we should completely compile, unless I messed up the compiler flag again. I mean, high probability that I did, but. So I can further knock this down because a bunch of these things I'm not going to use. Oh, this is a... okay. Makes sense. This 0 is an unsigned integer. Wait, is this an... What is this? Because the suggestion here is interesting. That implies this is an int. Nope, it's not an int. And something weird is happening with Docker. Okay, fine. Hey, things compiled. We don't know if it works, but it compiled. Okay, so next step, let me undo all this module stuff and see if that helps. Yeah. So I'm going to copy this file so that it is in Pathos. Okay, and then I'm gonna go to the package and just take out the dependency here and go back here, take out the import statement, and we'll just see what happens. No, it doesn't work. What if I put a dummy C file here as well? So now this should be considered a mixed language module. Maybe dummy C is the smartest decision. Oh no, feature not supported. Okay, at least it's explicit, right? Now we know. Okay, so we deleted that. Let me consider this. I don't know. Index store DB. Just some repo that I know have C stuff in it. Let's see how they organize stuff. So this is a tool This is, oh, do I not remember this correctly? I feel like there were C files in here before. Maybe they updated it. No, they are seeing a different path. Lib. I see. Whenever I say I see, Siri gets triggered. So here are their headers. Right. Maybe I should call this like, oops. I don't know, Linux headers or something. Right? And then, I mean, it's not really a header, but it is what it is. Okay. So now I have to come here, call this like Linux headers. Even helpers. Yeah, helpers is even better. Okay, so Linux helper has a stolen piece of code in here. Probably should credit the original author here. Okay. Okay, let's go back to the fun part. Writing Swift. Yay. So this is actually becoming increasingly inaccurate. The fact that we're calling it like Glibc, but because it doesn't work on non-Glibc stuff, it only works on Linux. But we'll deal with that when it comes up. So if I include this, we should compile, right? Or not. No such module, Linux headers. What is going on? Oh, Linux headers. That's what. Okay. So we the interesting part is we have a stat. That means we get to reuse a bunch of stuff. So for example, things like our files in Darwin that has this, right? Now I'm thinking I need to move this back to Yeah, I don't need to actually use this. Okay. So this is in path plus Darwin. If I go to metadata plus Darwin, where I call this, right? I can just paste this in here. And this is actually the value that gets in line anyways when I call this. Now, theoretically, we have a stat in the other place as well. So we can just take all of this, right? And put it... Wait, is this right? Aha, okay. Yeah, it's kind of right. Okay, so in theory, I think here what we need to do is call metadata and then give it the stat and the b time. Okay, and then we go to metadata implementation and say if we're dealing with Glibc, we'll have a time spec b time, and then this will be the b time. Everything else should be the same. Oh, this part won't be. Wait, I thought I... Yeah, it's this. Okay. Okay. Stat. Oh, yeah, I didn't call it stat. Path plus Glibc. It's S. Let's call it status. Because I think that's what stat stands for, right? Or statistics? Also, how do I test this? Oh, did I call it Statx over there? Right. These things don't exist because on Linux, they're called like slightly different names. They're called SD A-team, M-team, A-team, and M-team. Okay, what else? This size is not right. So it's an int. So we need to convert it to 64-bit. Interesting, interesting. So stop that. Anything else? So far, that's all the errors I can see. So how do we write a test for this, right? We can write a simple test as like get the stat for the current directory, which is just a dot. And it should work. Okay, we were compiling, so that's pretty good sign. So let's make sure it works. What if I just write a simple test? Metadata tests. Import pathos, import test, metadata tests. Oh. Wait, have I been using 2 indentations? Weird. Okay. Test metadata retrieving metadata. Okay. Why is this 2 spaced? Huh? I don't get it. Now it's 4 again. I don't know. I get it. Okay, whatever. So regardless of platform, I want to say path, right? Dot metadata, and this is gonna throw. So we need to make a throwing function, and then the first step is simply, hello. Okay, first step is actually assert not throw. And you really need to get the latest source-kit LSP where you have limited number of returned results, because this is choking my editor. No idea if this works, but there's some basic syntax error here. Okay. Was it not assert, not throw? XAT assert. I feel like I've done this before. What would it be? It would be current directory, working directory. No throw, not throw. Kind of makes sense. Okay. Did we throw? Swift build. Okay, this one failed. We've got an error. Error code number 2. No such file directory. Okay. What if it's the root? No such file directory. Huh. Let's debug. Is it path plus POSIX? Nope. Glibc? Nope. Darwin, right? Metadata, okay. Yeah, let's print this one out. Then return. $47. Yeah, it is the /. No such directory, huh? What if I say... Wait, now it's 0 failure. 1 failure. Sometimes it's 1 failure, sometimes it's 0 failure. Why? That's really unsettling. Huh. I thought current directory will guarantee a... Okay, hold on. Let's dig deeper. Dig deeper. We can delete this function, right? See, that time I had 0 failure. 0 failure, 1 failure, 1 failure, 0 failure, 0 failure, 1 failure. Why? I'm not following symbolic link. Wait, also, I feel like this is flipped. All stat function is like stat, except in the case where name is a symbolic link, else stat returns information about the link. Oh, right, it's not flicked. Flick. Follow link means we call stat, right? Okay, that's not a problem. Return value of function is a 0, otherwise it's -1. Error null indicates the number, and when it fails, we consistently get unspecified number error code 2, right? And 2 is no such file or directory. Which is interesting because it sometimes don't fail. What if I run this in Docker? I mean, the current directory, no matter where it actually is, should always exist. It succeeded that time on Linux. Succeeded again. Why does it periodically fail? Let's run it in Xcode and see what happens. Failed that time. Failed again. Failed again. Succeeded this time. Failed again. Failed again. Failed again. Succeeded. So this is the same behavior I observed earlier. What if I call this one? Yeah, it's just like, it's like a coin flip. Sometimes it works, sometimes it doesn't. Specified error code. And for sure, we're calling into this file, which calls into this, right? No, this. Okay. Okay. Oh, I think I got it. Ah, this is a nasty problem. Nasty problem. Haha. Oh my god. Why do I dig myself into this? Null termination. Whoops. God damn it. This problem is so nasty. Because this is a C string, so we need a 0 at the end. Oh my god. Yeah, this is a good indication that I shouldn't expose this as a public interface. So that's something to think about. Is there a similar problem here? Wait, what was that? Path plus Darwin. So we have path plus Glibc. Where we take the base address. Yep, same thing here. Need to add a 0 at the end there. Okay, everything else should be okay. Which begs the question, why do I need to do that twice here? Because all I need is yeah, I don't need this this complexity here, because I need the status anyways. Then I need to write this line of code. Stat sorry, weird sound came up. Stat version. Those two functions should have same signature, right? So I'm gonna do like if it's follow symlink, we just use this. Otherwise, we use. Oh no. Oh, maybe it will work. Okay, and then we get the then we can just call this. Then we take the result. Okay, so I think this will guarantee always success. Yeah. Okay. That was scary. That stuff is really scary. maybe the right thing to do here. Anyways, I think let's run the test again on Linux first. So I think I expected it to succeed. Yeah. Yep. Works just fine. Okay. Yeah. So I guess the next step is I want to clean up the C string thingy, which is really annoying. So that's in binary string, I believe. Yeah. Yeah, so I had to do the same thing for for string. I totally forgot about that. Okay, maybe I can do this. Public var C string. Can I do this? Which is self dot with unsafe mutable buffer pointer base address unsafe pointer of C char here, and I'm gonna add this. I wonder if this kind of defeats the purpose of having this in the first place. If every time I need to pass it around, I need to add a 0 at the end. Does that trigger a reallocation, a copy? Then it's not as fast as I want it to be. Yeah, I don't know. Okay, this is something, right? I know that. Let me switch to a more universal path because I believe this is a path that's acceptable on Windows as well. Since you're running this test unconditionally, I'd hope it's a valid test on Windows as well. Okay, so I think this should be the end of this stream. I'm gonna push up these changes, and we'll see what we can do. But anyway, it's very fun. I encountered challenges that I did not expect. I need to think about how to deal with this better. This is kind of one way to make it work, I suppose. But to be honest, I'm not super happy about this. But we'll see. Yeah. Anyways, thank you very much for watching. If you're watching this on YouTube, give this a like. And, I stream on Twitch, so give me a follow over there. Other than that, see you next time.